This is lesson 5.6, multiplying and dividing a polynomial by a monomial. We're starting with multiplying. Now remember, the distributive property said that we must multiply whatever term is outside the bracket by whatever term is inside. In this case, 2x is our monomial, and we're multiplying by 3x, and then we're multiplying by 4. So let's see what we get here. If we take 2x multiplied by 3x, we multiply the numbers, and we get 2 times 3 is 6. And we also are multiplying x by x. So we're going to put down our base x. Remember from our rules of exponents, if we multiply same bases, x times x, we're really going to add the exponents. And the imaginary exponent here is x to the 1, x to the 1. So it's really going to be x, 1 plus 1 gives you 2x squared. Okay? Then we're going to do 2 times 4x will give you plus the numbers. 2 times 4 is 8. X will just be plain x because there's no other x's to multiply it by, so we just remain x to the 1. Now, how do we show this with algebra tiles? So we can represent this with algebra tiles. We start with an algebra grid, which is like a little box, and we place the guiding tiles to represent each dimension. So the first one we have is our 3x plus 4, which is this polynomial right here. We've got 1, 2, 3 x's represented by yellow squares, long x squares, and we've got plus 1, 2, 3, 4, the number 4 represented by the 4 little boxes. Now on the other side, how much is it multiplied by? If we look over here, we've got the 2x right here. 1x, 2x. What we're going to do now then is we're going to multiply this number by this number and put our answer in here. So x times x will give us a big box x squared. So we'll grab one of those and we will place it in here. We'll keep going. Now this x times this x will give us another x squared, which goes into this box right here. And so on and so on. X by x gives you x squared. The other x by x gives you another x squared. And we're over here, x by x gives you another x squared, and here. So now we're on to this number 1 times x. What will that give us right here? Well, that will give us the plain old x. 1 times x is just x. So it goes here, and this can continue like this until you see what we're going to end up with is 4x is on the top box and 4x is on the bottom box. And you can predict that the answer for this, by counting up all our shapes, is 6x squared. Okay, so you'd have 1, 2, 3, 4, 5, 6x squared, and 1, 2, 3, 4, 5, 6, 7, plus 8 x's. So we're going to try that one again, and we are going to go to the next example where we do the same thing. We're going to take negative 4c times 2c, and we will get a negative number. 2 times 4 is 8, and we've got c times c, which is 1 plus 1, gives us c squared. Okay, and our second term will be negative 4c times negative 3, a negative times a negative will give us a positive, and we end up with 12c in this case. Okay, so if we look further again here, algebra tiles again, we will do this example. And so you can write down on the top box, you will have the polynomial in the bracket right here, 2c minus 3. So you've got 1, 2 of the c's, and you've got the red ones to indicate negative 1 to negative 3. And on this side, you can see you've got the negative 4c. 1, 2, 3, 4 negative ones. So what are we going to get when we multiply with these? We've got a negative x, indicated by the red, multiplied by a positive x. And that will give us what kind of x? It will give us a negative x. So that goes there. This one goes here. And we're going to repeat this 4 times on this column and 4 times in the second column. Okay, so our positive x times a negative x will give you a negative x squared. So we've got 1, 2, 3, 4, 5, 6, 7, 8 x squareds here, or in this case we're calling them c. Now if we move over to the number, we've got x, negative x, times the negative 1, and that will give us a positive x. And we will fill this in now. We can do this 4 times, and you get the picture. We should end up with 12 of those C shapes. Okay, we'll move on to the next example. So now we're just going to start with dividing. Dividing is just the opposite of multiplying. So what we want here is we're determining the quotient, or we're dividing negative 6w x, or w squared, plus 9w divided by this 3w. So we're going to start this one using algebra tiles. Okay, so the first thing we do is we're going to make our grid, and we're going to arrange this first polynomial on the grid. Okay, so the polynomial that we are starting with is right here. 1, 2, 3, 4, 5, 6 w squared, because they're the big shapes. And then we've got 9 w. So we've got this first one here in this section right here. Now we're dividing it by this one over here, 1, 2, 3 w. So you can see this is the 3w. What we want to do is our answer is going to be here. And you can see how this is the opposite of multiplying, because this answer times this bottom one will give you the inside circle. So what we're going to do is we're going to say, here we have a positive x, and here we have a negative x squared. So this is obviously going to be an x here, because x times x will give you x squared. Now, if you start with a positive x, how will you get a negative x squared? You're going to have a negative x here. So we will say that that is going to be negative x. Now we can go backwards or forwards. We can say negative x times positive x gives you negative x squared. So that's correct. We'll move on to the next one. It's similar, so we're going to say that's going to be negative x times the positive x will give you the negative x squared. Now we can move on to just the plain old x's. If we've got an x here, right here, and we want to end up with an x here, this obviously has to be a 1. 1 times x gives you x. Now, the only question is, will it be a positive or a negative x? If we have a positive x here, and we end up with a positive x here, we know we are multiplying by a positive 1, so we will put the positive 1 here. And if you multiply that one times this side one, you will get these all the way down, and you will do that 3 times. Okay, so positive x, or positive 1 times positive x gives you this positive x. Okay, so the answer is, if you start with your first polynomial, we're going to get the pen back. You go up here, and your answer here, this one here in the middle, and divide it by negative 3 over here, your answer is going to be right here. And we can look at it pictorially, and we can say what it is symbolically. So it is 1, 2, negative 2, and these boxes are referring to w's in this case. Negative 2 w's, and what are these? 1, 2, 3 positive, so plus 3. So that is our answer. When we take this polynomial and divide by 3 w's, we get this. Okay, now let's move on to the next example. We're going to rewrite every one of these, negative 3m squared over negative 3m. Positive 15mn over top of negative 3m minus 21 over 3m. Okay, and if we look down here, negative 3m divided by negative 3 divided by negative 3 gives you positive 1 over 1, which we don't need to write, and we ended up with no number in front. Now, let's look at our m squared divided by m. What we've got here is we have to use our rules of exponents. We've got m and m, which is the same base. We're going to use this exponent of 2, and the exponent here is an imaginary 1. And because we're dividing, we will take the exponents and subtract. 2 subtract 1, and we end up with 1. m to the imaginary exponent of 1 really equals plain old m. Okay, let's move on to the second term, and we've got 15mn divided by negative 3m. So what we're going to do is divide the numbers. 15 divided by 3 gives you a negative 5. So we could have written subtract 5n, or we can write in brackets a negative 5n. Now let's look at the variables. M over n, m. So this is an imaginary 1, this is an imaginary 1. 1 take away 1 is 0. M to the 0 means there are no m's, the m's go away. The other way you can think about it is say m divided by an m makes them go away. Now we've got an n to the 1, no n's on the bottom, so we're going to end up with n to the 1, which is just n. Now we're going to look over here at the subtract 21m divided by negative 3m. Negative 21 divided by negative 3 and m divided by m, or m1, 1 subtract 1 gives you m to the 0, which is no m's at all. They are gone. So all we're left with here is a plain constant. Okay, so the procedure for dividing is very similar to when we were dividing with a constant. The only thing you need to remember now is that you're going to have to use your rules of exponents for the variables. So if you've got m squared on the top, it's a 2, m on the bottom, it's m to the 1, 2 minus 1 will just leave you with 1. So use your subtracting exponent rules for that. Here's a few examples we should do that are just to practice what we're doing. So we've got here, we're multiplying. We're going to do the distribution rule. 2 times a negative 3 will give you negative 6. And we've got x times x squared. This is just an imaginary x1. We've got a multiplying, so we're going to put the x down. We're going to add the exponents. 2 plus 1 gives you x to the 3. Now let's write down 2 times 4x squared, or xy, will give you a plus 8 x1 plus 1 gives you x to the 2 y. There is only one y. Now let's move to the last term, and that will be 2 times negative y will give you a negative 2, and there's 1x, and there's a y squared, no y's to multiply. Okay? Let's move down to the bottom here, and we're going to do the same thing as we did with dividing. Now what we're going to do is we can rewrite it, or we can just do it in our head. We can go this first term here. It's a positive term. Divide by this positive term. So we're going to do the numbers first. 9 divided by 3, and that gives you 3. Now we've got x squared, and we've got x. So we've got 2 subtract 1x will leave us with 1x. X, and the y's. y1 here, not dividing by any y's, we're left with y1. Let's move to the next one. We've got a negative 12 divided by a positive 3. Our answer is going to be negative, because a negative 12 divided by 3 will give us negative 4. Now we're taking this y, divide by y, that gives us no y's, they're all gone, so, or no x's, sorry, x divided by x is no x, and then we're left with y squared divided by no y's, we're left with y squared. Now let's go to the third term. It's a positive 6x squared. So positive 6 divided by 3 gives us a positive 3. 3x's divided by 1x, 2 minus 1 will leave us with x squared. And we're on to the last term, divide by this, and we get 5 divided by 3. We're going to have a 5 divided by 3. We'll leave it as a fraction for now, because that's where we like to leave them. X divided by x, or x1, subtract 1, 0 x's, no x's are left. Okay, and this is what we're left with. Of course, if you ended up with similar terms that had similar terms, then you would have to simplify. But in this case, we don't have any other xy's, we don't have any other y squares, we only have this 3x squared, and we only have one kind of number. And that's all there is to it.